you solve it like you would kind of a regular equation?
Yeah. It's not a lot of difference. Every now and then there's a difference, but most of the time there's not much difference. So what would I do?
So you would add 3 to both sides? Yeah.
There's your solution. N is greater than 0.
Okay.
Let's take a slightly more complicated one. Let's do 8. Minus 6b is greater than or equal to minus 30. Now this is where it's slightly different than an equation. How do I solve this?
You would divide by -6.
And whenever you divide by a negative number, what do you have to do to the inequality sign?
You have to flip it.
Right. So this becomes b is less than or equal to 5. And that's the only difference when you're working with inequalities as opposed to equations. You just always have to be wary of dividing or multiplying both sides by a negative number. The moment you multiply or divide both sides by a negative number, you flip the sign. Let's do another one. Y over minus 4 is greater than or equal to 13.
All right. So for that one, you would multiply by -4.
Okay.
And would you switch the sign for that?
Yes.
No.
Yes. When you're dividing or multiplying by a negative number, doesn't matter which. Division or multiplication causes you to turn that thing around.
Okay.
Let's find a little harder one. It's the first thing I'm going to do here.
You would multiply by -5 and then switch the sign, right?
Well, you mean divide by -5?
Yeah.
In other words, the -5 right now is multiplying. So to do the reverse of that, we want to divide. And yes, you're right. Divide by -5, and that switches the sign. So now I have t plus 11 is greater than the number 12, which means t is greater than 1. It's only when you're multiplying or dividing that you have to worry about that sign or the direction of the inequality. When you're adding and subtracting, you don't do anything. In other words, I subtracted 11 from both sides here, but I did not re-switch the sign.
All right.
Only during multiplication or division. And sometimes when you're taking square root. In other words, it's not going to be on this page, but if I had x squared is greater than 1, and I take the square root of both sides, I cannot say x is greater than 1. The answer is x is greater than 1 or x is less than -1. So it gets a little more complicated when you have to take square roots of both sides in order to get the answer. But that's Algebra 2 or even pre-calc, so I don't think you have to worry about that yet. Let's look at 12. 3 is less than or equal to x plus 5, which is less than or equal to 9. How do I solve this for x?
So you would you do everything to both sides of the equation?
Yeah, you can treat it just like a regular inequality, even though there's two inequality signs. In other words, I can subtract 5 from every part of this thing, from the left, the middle, and the right. So when I subtract 5 from there, I get minus 2. Doesn't do anything to the signs. When I subtract 5 from there, I get there, and there's your answer. X is greater than or equal to minus 2 and less than or equal to 4. So on a number line, it would go from minus 2 to 4. Now, where it gets kind of interesting is where you have absolute value. This is a little different. Let's talk about this. When you have absolute value combined with inequalities, it means two things. It means x plus 5 is less than 12, or what?
Would it be negative x minus 5?
Never change what's inside the absolute value signs.
Okay,
So it's always the same, but now I have to switch the direction of the inequality and the sign on the number, like that. So if I had x minus 2 is greater than or equal to 6, what does that mean?
It means that x minus 2 is greater than to equal, or is greater than or equal to 6, or x minus 2 is less than or equal to negative 6.
Yeah, and then I just solve each equation separately. In other words, this one means x is greater than or equal to 8, and this one means x is less than or equal to minus 4. So that would be your solution.
Okay.
And the thing to remember is never change what's inside the absolute value sign. In other words, a lot of people want to mess with this and make it a negative x minus 2 or something. But the only thing you have to change is the direction of the equality and the sign on the number. Now, if this is just an equation, changes everything. What's that equal to? It's still equal to two different things, but the first one is still this, or what?
Or x minus 2 is equal to negative 6?
Yeah, that's the only thing you have to change in an equation, is the sign on the number that's on the other side. In other words, I didn't have to worry about switching the direction of the inequality. There isn't an inequality. It's an equation, so it handles a little bit easier with equations.
All right.
See if they got anything else here that's interesting. Yeah, they want us to graph some of these inequalities. Let's do that. We don't have much time, but we got a little bit. Let's take a real simple one. X is greater than minus 6. That is a vertical line, and the solution is everything that's to the right of that line. It's a dotted line because it's greater than, not greater than or equal. Okay? The second one, y is less than 2. Well, y is equal to 2 is a horizontal line. And when it says y is less than that horizontal line, it's everything there.
Okay.
All right, now let's jump a level of complexity. Let's look at 18. 3x plus y is greater than or equal to 7. Well, that's the equation of a line. In other words, it's almost the equation of the line. In other words, if I move the 3x to the other side, I get this. Look at that. That's y equals mx plus b format, right?
Okay.
So if I were to graph that, I would go to 7. I would have a slope of -3. Now, which side of that line should I shade in? Based on this.
Would you shade in the right side?
Yeah. And it's not so much the right side as it is the top side. In other words, the way I answer the question is y is greater than this line. So I go to the y-axis and I find any point at all that's greater than that line. Well, that's greater, that's greater, that's greater. All of those points are on this side of that line. And that's the way you do it, is you just look to the y-axis, always, assuming your inequality has y all by itself on the left. Then you look to the y-axis only to determine which side of the inequality you're on.
All right.
All right. Let's stop there. David, it's good to talk to you again. Let's see, what are we doing next week? You're not preparing for finals at all, huh?
No, we don't have any.
Okay. You still want to meet Tuesday?
Yes. Unless you
Does Wednesday work just as well for you?
Yeah.
Do you mind if I switch it to Wednesday? And you
No.
can see why. My Tuesday is completely jammed because everybody has finals next week. And I got nobody on Wednesday. So if I could move you to Wednesday just for next week, and then we can talk about what we're going to do next year and all of that. I mean, we'll go back to Tuesday after next week because you'll be on Christmas break for a few weeks. We won't have it.
Yeah, I'll be on Christmas break the week after the next
Okay.
week.
So next week's the only one that I would like to switch it to Wednesday at 4:30.
Okay.
Okay, and then that opens my Tuesday and up a little bit. I appreciate that. David, I will talk to you next Wednesday. You want me to still text the meeting ID to Sarah?
Yes.
Okay. Sounds good. Talk to you next week.
All right. Thank you.
Bye-bye.